annuity and perpetuity. So annuity, the fund, they're both investments, whereby annuity is an investment that after a certain period of time, their fund will be exhausted. It's based on time frame. After that time frame, the fund will be exhausted. All right, whereby perpetuity, it's indefinite and return. So now let's have a look at how it's done. Recurrence relation for annuity. So this is the payment that the bank is making to the person who made the individual, the investment, I should say. So after a certain period of time, that's exhausted, that's finished. All right, let's have a look at an example based on this concept. As part of our postgraduate studies, Margaret has been awarded a writer in residence, a scholarship of $8,500 for 4 months at a local college. And the money is invested in annuity that pays 4.5% annual interest compounded monthly. So this is the payout that she's going to get from the annuity. So that's your D value. So if you want to find out, if you want to establish some sort of a recurrence relationship, so this is the amount that was invested at the beginning. After a certain period of time, that fund will be exhausted, will be finished. All right, so that's the D value. So the R value will be so that needs to be converted into monthly basis. And this is our recurrence relation. After a certain period of time, the fund will be exhausted. It's a recurrence, so that means we have to use the previous value in order to find out what will be. We can also use finance solver to find out what will be the fund remaining after 5 months. Or we could actually use a recurrence relationship in order to. So that means if we have to use a recurrence relationship, so that means we have to use the previous value of the investment, because that does change every year because she's getting a payout. So that means if I want to get the first year, how much or the first month, I should say, what will be the balance of the investment. So this is what I'm going to do. And that's going to be V1 will be. So that's going to be the balance of the investment will be after 1 year, after 1 month will be, and make sure you keep all your answers to decimal places. And V2, so that means you need to use V1 in order to get V2. So that basically means whatever value you got from here, do not approximate whatever the value you got from the calculator in your calculation. Make sure you use that. Your final answer, that's where you do the approximation. So all the values you got from your calculator, just put them in, and so on. And that's how you do it. That's basically what the recurrence relation will be, and that tells us what will be the balance of the investment after a period of time. But if you're using the finance solver, because this is the money she's getting from the annuity, so that has to be positive, and that is negative, and your future value after 4 months, that's how you're supposed to be doing. Because if you're getting money from the bank, the PMT of your finance solver has to be positive. But if you're giving money to the bank, it has to be negative. But with the recurrence, just do it this way here. So after the second month, that's the balance of the fund. So eventually the fund will run out. In other words, they will be exhausted. That is basically an annuity funding or investment, whereby perpetuity is an annuity. In other words, investment where permanent invested sum of money provides irregular payments that continue forever. So the time frame is indefinite. So if you happen to use the finance, well, this is how you find out the regular repayment. And also the interest rate needs to be changed. The compounding period, you need to take that into account if you happen to use, if you happen to find out what the D is. So let's have a look at example based on this concept. And if you end up using the finance solver, so you make sure the N has to be 1 for perpetuity, because it doesn't change. So one thing, the take home message for perpetuity is basically the same. After a period of time, your investment will always be the same. So if it was 100,000 that you invested, you still got that 100,000 after a period of time. So that sum of money with perpetuity does not change. So just be mindful of what the question is asking. It's very important to read what the question is asking. And the other thing I want you guys to be mindful of, the D value for both annuity and perpetuity, because you're receiving money, it's an investment, the D value will be positive. Whereby the present value, because it's investment, you're giving money to the bank, the PV will be a negative value, whatever that happens to be. But when you're writing your answer, don't write as a negative, but when you're using a TI or the CAS, make sure that is negative, whether you use the CASI clasper or the TI, whichever one you use. Alright, let's have a look at this example, whereby Rotary Club has 100,000 to set up a perpetuity as a grant for the local junior sporting clubs. The club invests in bonds that has a return of 5.2% per annum, compounded annually. So the compounding period is actually so this time here the compounding period is 1. So this is only if it's quarterly. This is for monthly. So for this case here, and if you determine the amount of the annual grant, so that means we are finding the D value. So we're going to use R of 100 V naught. It's going to be 2.5 over 100, because the compounding period is annually, so that's basically 1. So if I have to multiply that, the compounding period, and the amount that was invested is 100,000. The investment will make a 5,200 return every month. That's the amount. So every year, I should say. All right. Now, and calculate the interest compounded monthly. Annually. So if it's monthly, so that means you need to change that. So this is basically, if you happen to use your finance solver, PPY, that needs to be 12. Yeah. And this is asking us the interest rate. So this is how you're supposed to be doing if you happen to use. So the amount that was invested was 100,000. Let's get down there. So let's just put down 1. And we want to find out that, and this is going to be the 100,000 that was invested. And what's the return we're getting from this 100,000? It's going to be 5,200. So this is actually compounded monthly, required to make a 4 equal monthly payment of every 3 months. So I'll give you answer to this one. Well, that's going to be the compounding period, has to be 12. So the return is 1,500. The future value and the present value will be the same, except that it's going to be a positive. All right, and the compounding period, I think that was quarterly. and we put the cursor up there, you press enter, and actually that was monthly, was it? And let me just find out. Alright, now every quarter, well, this is going to be a monthly one, so that's going to calculate the interest converted monthly required. Alright, now okay, so times, so that's going to be investment. Let's go back to that one there. Calculate the interest rate required to provide 4 equal payments of, so that's basically 4 equal payments per year. So 1500. Alright, I have a compounding period. Press enter that one there. Alright, so this one here, calculate the interest rate converted monthly required to make a 4 equal. Since the 1500 is actually paid on every 3 months, so that means the PPY, just keep down 4, and the CPY this time also keep it 12. So that's what you need to change in order to answer that question. So let's do that. Let's get down. That's going to be, the answer was 5.97. 5.97. Give your answer to 2 decimal places. So B, the R value we got was 5.97%. I have to use this one here. Could do the same thing again. So just keep down because it's perpetuity. So that has to be 1. So finding out the interest rate in that case. So that's going to be minus 100,000. And this is positive because it's an investment. And that is going to be, and this one we keep it for every 3 months. That's how much, because it's for 3 months. So put the cursor there and solve. And you get 5.972 decimal places. That's how we do it. Well, let's have a look at another example on this concept. Alright, this is an exam question, which is 360,000 is invested in perpetuity at an interest rate of 5.2 per annum. The monthly repayment is that the investment actually does provide is going to be 1560. After 6 years monthly repayment, how much money remain in the investment in the perpetuity? So that's basically a trap. So you still have got 360,000, even though it has been making a repayment after 6 months. Remember that perpetuity doesn't change, it keeps the same. All right, that's the last question we're doing in this. All right, okay, I hope that makes things clear.